Think of a crowd clapping along with a song. At first, they all start off out of sync with each other, but the longer they listen, they start to sync up with each other. So, which one makes it easier to clap along? Listening to the song for a longer period of time or a shorter period of time? According to that example, you would obviously pick longer. So, let's apply the same concept to sound waves. Take this piano note, for example. You could be very confident that this is a C, but by comparison, it's very hard to be confident in the pitch of this clap.
Think about it. There's this relationship between time and certainty. The longer you listen for, the more sure you are. And when you're looking at a Fourier transform, which is the mathematical deconstruction of a wave into its respective frequencies, there's this relationship between the amount of wave that you have and the certainty behind the frequencies that construct that wave. Essentially, less wave means less certainty, and vice versa. So what's the deal? I'm just being Captain Obvious here, aren't I? Well, bear with me, because according to quantum mechanics, matter behaves like waves all the time. You see, in his 1924 PhD thesis, Louis de Broglie proposed that matter could act like a wave, and this wave, called a matter wave or a wave function, determines how likely a particle can be found at a certain position. He also proposed that a particle's momentum was inversely dependent on its wavelength, and as you may recall, wavelength and frequency are dependent on each other. You see where I'm going with this, right? We could observe the same exact Fourier trade-off with position and momentum. When we look at a wave function of a particle with a well-defined, localized position, it's like the clap from earlier. There isn't much wave to work with, so we can't be certain about the frequency, which means we can't be certain about the wavelength, which means we can't be certain about its momentum. On the other hand, when the position is uncertain, it's like the piano note. Because we have a lot of wave to work with, we could be very certain about its momentum. This is called Heisenberg's uncertainty principle.